Hello everyone, once again welcome to PM Networking. Hope you all are doing great. Today in this video we are going to understand OSPF external metric type. This is a small topic of OSPF we will cover right maybe in 50 to 20 minutes, theory plus practical. First we will understand theory part that what it mean of external metric, right? While redistribution we are using this metric type, metric type 1 and metric type 2. Actually we have two types of external metric in OSPF, so we will understand both. Okay, while redistribution, when we perform redistribution on any router, as you know, that router will start acting as ASBR router, autonomous system border router. This is concept of OSPF, right? It should be clear to everyone what is ASBR. Like, this is my topology. In my topology you can see we have two routing domain. One is OSPF area 0 and one is EIGRP S number 10. Doesn't matter which routing protocols I am using in this domain, right? But I am not using OSPF. This is different routing domain. Maybe EIGRP, maybe RIP, maybe RIP version 2, maybe BGP or any other routing protocol. This is different routing domain and this is OSPF domain. So router 2 and router 3 have one interface in OSPF and one interface in other routing domain. So these two routers will act as ASBR. So now in this scenario I have two ASBR. This is router 2 is my, let's say, ASBR 1 and router 3 is my ASBR 2. So if router 1, or let's say router 1 is connected with one switch and here I have some user, and this user, let's say this user or this user, single user, want to communicate with 50.1.1.1, which is located on router number 4. So this PC will forward traffic to router 1. Now router 1 have two choice to reach in this network. It have two autonomous system border router. For router number 1, the router number 1 have two border router 2 or router 3. Either it can forward traffic to router 2 or to router 3. Yes or no? It have two ASBR. So means how many exit point we have to enter in this routing domain or to exit from this routing domain? 2. We have 2 point, right? Means these prefixes will enter in OSPF domain from two side, from this side also and from this side also. Am I right? Now guys, try to understand what is metric type. This is my topology. Hope this topology is clear to you. I have only configured IP addresses on these devices. I will configure OSPF in this domain and EIGRP in this domain. After that we will perform redistribution, then this router will become ESBR router. After that I will show you the database or routing table, whatever things are required, right, to make you understand metric type. So first of all, keep in mind, whenever router advertise external prefix in OSPF domain, it include a cost in route. Let's say what I am saying, that whenever a router redistribute external prefixes in OSPF domain, like when we will configure redistribution on router number 2, router 2 will advertise all prefixes of EIGRP ES number 10 into OSPF area 0, and while redistribution, router 2 will add some metric, will add one metric, maybe that metric will be 20, right? In the same way, router 3 will also, while router 3 will advertise prefixes of EIGRP 10 in OSPF, it will also add metric, let's say 20. So it is clear that whenever ESBR router advertise prefixes in OSPF domain, it will add one metric, right? And OSPF support two types of metric, type 1 and type 2. Type 1 and type 2. OSPF support two types of external metric. While redistribution, right, either it will use type 1 metric or type 2 metric. Now understand what is the difference between type 1 and type 2. Guys, the difference between two metrics is how OSPF calculate cost to for the external prefixes. Like when these prefixes will enter in OSPF, how OSPF is going to calculate cost for external prefixes. This is how these types of metric is different. Getting my point? Type 1 external metric is sum of internal cost as well as external cost. So this is what, this 20 is what, actually ASPR is including one cost, that is 20, while redistribution, that means this is external cost. Yes or no? This is external cost, that whenever outside prefixes or external prefixes will come in OSPF domain, all prefixes will come with this metric, that is external metric. Okay, so this metric actually when you will check database of router 1, in the database of router 1 there will be some LSA 5, because ASVR will advertise these prefixes, right, in the form of LSA 5. And if you will open this LSA in detail, so you will see the metric, and that metric will be your external metric, that metric will be your external metric, because that metric is coming in LSA, in LSA 5, means router 2 will add one metric. That metric is known as, we can say, link state metric. Like if I will check, I will show you the database of router 1. In the database, external LSA of, let's say, 50.1.1.0. So both router will advertise these prefixes with one external metric. So type 1, when we will use type 1 metric while redistribution, then router 1 will calculate total cost, means external cost plus internal cost. Here also we have some cost to reach ASBR. So cost between router 1 and router 2 is, let's say, 10, and external cost is 20. So total cost will be what? Total cost will be 30. Means this is the behavior of type 1 external metric. In type 1 external metric is sum of external metric as well as internal metric. We can say sum of external metric plus internal metric. But if I will talk about type 2, so it will use only external metric. Getting my point? So if I will advertise or redistribute by using type 2, then router will install these prefixes in their routing table with external metric only. If I will advertise it with type 1, then router 1 will install these prefixes with total metric, external as well as internal. I will show you practically also, don't worry. Then maybe now it is confusion for you, but once I will perform practical, it will be very clear to you. Okay, just wait. So type 2 external metric use only external metric, and type 1 external metric uses sum of internal as well as external. And guys, when we redistribute, by default OSPF uses type 2 metric. By default OSPF uses type 2 metric. Now let me show you the practically how it will work. See, and one more thing guys, metric type is used for path manipulation. Here we will discuss that also. Let's say by default both router is advertising external prefixes with which type of metric? With type 2. Let's say T2. Here I am writing this one is also advertising with type 2, but type 1 is more preferable than type 1. Type 2 is more preferable than type 1. So now router 1 will do what? Router 1 will perform load balancing for these prefixes, because both ASBR are advertising these prefixes with equal cost. From this side also it will type 2 it is ASBR 1 is advertising external prefixes with type 2. So router 1 will use only external metric, that is 20. And from this side also, when router 3 is advertising by using type 2, so it will also advertise with 20. Getting my point? So router 1 will perform load balancing. But in this scenario, if you don't want to perform load balancing, let's say I want to make router 2 as transit router. What I want, whenever router 1 need to forward traffic in this domain ESGRP10, router 1 should always forward traffic to router 1. So here we can do what? We can change the metric type. So now when ASBR 1 will advertise external prefixes in OSPF, it will advertise with type 1 metric, and router 3 means ASBR 2 will advertise with type 2. And as you know, router 1 will receive external prefixes with both ASBR, it will compare the external metric type, and T1 is more preferable than T2, so it will install all these prefixes via router number 2. Getting my point? Now let me show you guys practically. So first of all, let me enable OSPF on this router. Let me do one thing. Here what I am going to do, let me check the first initial configuration. Enable, so IP protocol, we don't have any protocol, so IP interface brief exclude unassign. So this is my IP configuration here, right? Now I am going to configure OSPF. So first of all, router OSPF process ID 1, and then router ID is, let's say, 1.1.1. Then go to interface range F0/0 and F1/0. Here I am going to say IP OSPF 1 area 0. This is how I enable OSPF on router number 1. Done. Now let me configure OSPF on router number 2 as well. Enable config T router OSPF process 1 and router ID is 2.2.2.2, exit interface F0/0, and this interface is in area 0. OSPF area 0. Done. I have enabled OSPF on router number 2 also. Soon neighborship will come up between router 1 and router 2. So IP OSPF neighbor, now you can see neighbor is in two-way state. Soon it will come in full state. Let me configure R3 now. On R3 also I am going to say router OSPF process 1 and router ID 3.3.3.3, exit interface F0/0, IP OSPF 1 area 0. Done, guys. Now here you can see OSPF neighbor on router number 2. Okay, neighborship is full. Done. And from router number 3 also you can see neighborship is full. So IP OSPF neighbor. So now we have OSPF neighborship between router 1 and router 2 as well as router 1 and router 3. Now I am going to configure EIGRP on router 2, router 3 and router 4. So let me start from router 2. Now say router EIGRP ES number 10 and network 24. The network which is running between router 2 and router 4 is this one, 24.1.1.0. Say no auto summary as well, let's say. Done. I've configured the EIGRP on router number 2. Let me configure EIGRP on router 3. Config T router EIGRP ES number 10. Say no auto summary and network. Just I need to add 34.1.1.0. This is the network between router 3 and router 4. Now let me enable EIGRP on router 4. So here I am going to run network command 0.0.0, router EIGRP 10, no auto summary, and network 0.0.0.0. This command will enable EIGRP on all interfaces. Done, guys. Now let me check the routing table of router 2. So IP route EIGRP, it is receiving these prefixes. Yes, you can see it is receiving these all prefixes, and this is cost metric of EIGRP. In the same way, let me check router 3 is receiving this prefix or not. So IP route EIGRP. So you can see router 3 is also receiving these prefixes. Now I am going to perform redistribution, because now on router number 1, if you will run command so IP OSPF border router, you can see we don't have any ESBR. Now I am going to perform, and on router number 2 also you can run so IP protocol command to check border router. So this router is not ABR, neither ESBR. Okay, so now I am going to perform redistribution. Config T router OSPF process 1 redistribute EIGRP ES number 10 and subnet. That's it. Let me copy this command, and I am going to paste this command on router number 3 also. So router 3 config T router OSPF process 1 and redistribute EIGRP ES number 10 subnet. Right now, after running this command, let's say on router number 2, if you will run command so IP protocol. So IP protocol, first of all, you can see this router is, it is an autonomous system border router. This router is ASBR, and in the same way router 3 is also your ASBR. So IP protocol, by running so IP protocol command on router number 3 also, you can see it is an autonomous system border router. So now router 1, router 2 and router 3 both are ESPR. Now let me take you to router number 1, guys. And so IP OSPF border router, you can see 2.2.2 and 3.3.3, both are ESBR. Both are ESBR. And cost to reach 2.2.2 is via 12.1.1.2 is 1. Cost is 1. Cost to reach 3.3.3 is also 1. Let me show you the routing table. So IP route OSPF, it is receiving these 50 prefixes, yes, and it is performing what? Load balancing. Because you can see here it is clear that O E2 means metric type. When metric type is E1, then here metric type will be type 1, external metric type will be type 1, then here symbol will be OE1. When metric type is type 2, then symbol is OE2. E2 means metric type 2, and both routers are using what? E2, metric type 2. So you can see cost is 20. That means this is link state cost. This is link state cost, external cost. How we can verify it? We can check database of this router. See, on router number 1, we are able to see some external prefixes from both ESPR router, yes or no? So I am going to check database. So IP OSPF database. In database, you can see these prefixes are here in the form of which LSA? In the form of LSA 5, external LSA. And who is advertising these prefixes? Router 2 as well as router 3, 2.2.2 and 3.3.3. I am going to open any LSA, any external LSA in detail, right? So IP OSPF database and then external, and let's say 50.1.1.0. You can see, guys, metric over here is, metric is what? Metric is 20. Via which router? 2.2.2. When 2.2.2 is advertising, it is advertising with metric what? 20. So this is metric in link state, means this is external metric. This is external metric. And when router 3 is advertising, router 3 is also advertising with metric 20. Getting my point? That means by default, redistribution metric type OSPF uses which type, which external type of metric? So type 2. Okay. And in type 2, as you know now, metric is from metric is only external metric, not total metric. And if while redistribution, if I will define metric type or type 1, now on router number 2, guys, I am going to run one more command here. Router OSPF process 1, and I am going to remove this command. Let's say no over here. Done. And let me run same command again, and this time I am going to say metric and then type and 1. So I have advertised all external prefixes in OSPF by using which type of metric? Type 1. So this time router 1 will not perform load balancing. You know why? So IP OSPF, so IP route OSPF, you can see these 50 prefixes. Next hop IP address is 12.1.1.2, means it is forwarding via which router? Via router number 2. And metric is what? 21. Metric is 21. And so IP OSPF database external and 50.1.1.0. Again, I am going to open the database external LSA of 50.1.1.0 in detail. See, this time again both router is advertising, router 2 is also advertising with what metric? With metric 20. And router 3 is also advertising with what metric? With metric 20. Done. There is no any difference. But in the routing table, router have installed which path? Via router number 2. And what is the total metric? Total metric is 21, because so IP OSPF border router, because cost which is coming in LSA means external cost is 20 in the database, and cost to reach 2.2.2 is 1. So total cost is 21. And as I told you, via this path through router 3, cost is 20, but E1 is more preferable than E2. So that's why it have installed this prefix via which router? Via router number 2. So now you can see router 1 is not performing load balancing. Done, guys. Now router 1 is not performing load balancing. And again on router number 3 also, if I will change the metric type, again router 1 will start performing load balancing. Router OSPF 1 redistribute subnet metric type 1. Now both router is advertising external prefixes with same metric. Now again I am going to show you, so IP route OSPF, it is performing load balancing. It is performing load balancing. And again, see, this time matrix type is 1 from both sides. So from both sides you can see matrix is what? Total 21, because matrix which is coming in update means link state matrix is 20 and matrix to reach advertiser router is 1. So total cost is 21. Getting my point? And still, if you want, you don't want to perform load balancing, you want to send traffic, all traffic via router number 2. So we can increase some matrix on router number 3. So while running this command here, I can say matrix and not 20. By default, OSPF include what matrix? 20, and here I am going to set in going to tell to router 3 that advertise external prefixes with what matrix? 150. Now it will advertise all external prefixes in OSPF with what matrix? 150 matrix. Now again on router number 1, if you want to check routing table, so IP route OSPF, you can see it is not performing load balancing because best path is via router number via which router? Via router number 2. But if router 2 will goes down, interface F0/0, let me say shut down. And now I am going to show you the routing table of this router. You can see, sorry, you can see now path is available via router number 3 and total cost is 151, because router 3 is advertising external prefixes with what matrix? With matrix 150. Here you can see on router number 3 I have set 150 and matrix to reach 3.3.3 is 1. So total cost is 151. Okay guys, so these are concept of external matrix type in OSPF. Hope it is clear to you. If yes guys, please hit on like button, and if you have not subscribed my channel, please subscribe this channel as well. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.